Hi, this is Coach Dorf. We're going to look at another homework problem from section 5.3. So here you're given a limit as n goes to infinity of 1 over n times parentheses 1 over n squared plus 4 over n squared plus 9 over n squared plus dot 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 plus n squared over n squared. And the question asks you to evaluate this limit by first recognizing this as the sum as a Riemann sum for a function. So in other words, what we're going to try to do is rewrite this as a Riemann sum and then use the definition of integrals to write it as an integral and then evaluate the definite integral to get our answer. So the first thing is we're going to try to rewrite this sum. So I've got 1 over n squared plus 4 over n squared plus 9 over n squared plus dot 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 plus n squared over n squared. Well, it looks like one on top I have is 1 squared plus 2 squared plus 3 squared down to n squared. So I could write that as a sum, I equals 1 to n. And on the top, I'm going to put I squared. And on the bottom, it doesn't change. It's always n squared. So we put that as n squared. So again, I look at that and I say, what do I get on top? I get, when I is 1, I get 1. When I is 2, I get 4. When I is 3, I get 9, all the way down until I equals to n, and I get n squared. So that matches. So then our limit in the original problem, the limit of 1 over n squared plus 4 over n squared plus 9 over n squared plus n squared over n squared is equal to the limit as n goes to infinity of the sum I equals 1 to n I squared over n squared times 1 over n. Now, does it matter if I put the 1 over n before the I squared over n squared or after that? It doesn't really matter. Either one is right. So that is another way I could write this limit that we have here. But this is, if I think of this as a Riemann sum, this is a Riemann sum. So recall the definition of the integral. And that says, definition of the integral said that if I had the limit as n goes to infinity of the sum I equals 1 to n of f of x sub I delta x, that equaled the integral from a to b of f of x dx. So we're going to try to rewrite this Riemann sum as an integral. Then once we've got the integral, we'll evaluate it using the fundamental theorem of calculus part 2, and we'll be done. Okay, we have in this problem the limit of the sum I equals 1 to n of I squared over n squared times 1 over n. And so I'm going to equate these two parts together. And when I do that, what do I notice? Well, that suggests to me that, that delta x is 1 over n. But recall delta x equals b minus a over n. So this means that b minus a is 1. Okay, next thing I've got in my red box is that f of x sub I equals I squared over n squared. So this suggests to me that f of x is going to be x squared. And then I remember that x sub I is a plus I delta x. So in this case, that's a plus I over n, right? And when I look at this, then if I do, let's see, I'm going to do this here. That suggests, because I have here in purple this a plus I over n, and I have f of this, and I have f of that. If I look at those, what I should have from, I guess from this purple one here, this is suggesting to me that x sub I is I over n. Because then if I put f of that, we get I squared over n squared, because I know since f of x equals x squared. All right, now I've got also though that x sub I equals I over n, x sub I equals a over I plus n. So that's all going to suggest to me that a has to equal 0. Okay, a plus I over n. Okay, so then going back to what we have, so since a equals 0, and we know that b minus a equals 1, that gives me b equals 1. And then recall what we did before, that f of x equals x squared. So my Riemann sum, the limit as n goes to infinity of the sum I equals 1 to n of, and what did I originally have up here? I had I squared over n squared 1 over n. That's going to equal the limit, the integral from a to b of f of x dx. Okay, but we know what a, b, and f are now. We know that a is 0, b is 1, and f of x is x squared. All right, so now I can use the fundamental theorem of calculus, part 2, the integral 0 to 1 of x squared dx can equal 1/3 x cubed, evaluated from x equals 0 to x equals 1. And when I plug those in, I get 1/3 1 to the third power minus 1/3 0 to the third power, and that all just equals 1/3. And so my original limit there, if I were to do that, I get 1/3. So again, what did we do in this problem? We took our original limit, we rewrote it using the sigma notation so that we had a Riemann sum, and then we used our definition of the integral and connected it to the Riemann sum to rewrite the Riemann sum as an integral. And then we used the fundamental theorem of calculus part 2 to evaluate that integral. And that was then the answer to the limit of the original problem. All right, hope that helps.